over inches squared over, what is it? Pounds per second squared over inches. Okay. Close that. Now we just create the model like we've always done. Go to modeling. We're going to create 3 nodes and 2 elements. So create nodes, the active coordinate system. Node 1 is at 0, 0. Node 2 is at 100, 0. And node 3 is at 200, 0. And now we'll create the 2 elements between those. Go to elements, auto-numbered through the nodes, create element 1, and create element 2. That's pretty basic, right? Everybody knows we've been doing that all semester. No questions there. So this is where things change. We go to solution when we need to change the analysis type. Similar to how we changed it when we did a modal analysis, we need to change it to a transient analysis. So you go to solution, analysis type, new analysis, and you change it to transient. And then you click OK. And now this menu is asking you, do you want to change any of the defaults? And you can just click OK. You're not going to change any default settings here. Now, before you close out of the analysis type, you need to go into solution controls. And let me just draw this out on the board. It makes a little bit more sense what we're doing here. So there's 3 things you need to do. You need to define the time at the end of the load step, which we see here is the load is applied at 0.001 seconds it's maxing out at 1,000, and at 0.002 seconds it's back down to 0. So we just need to make sure that the time at the end of the load step is larger than this, so we can look at the response to that load. So time at the end of the load step, we can do 0.005, just to make sure it's longer than the load we're applying here. And now when we go to number of substeps or time increment, you can use either of these 2. But I like to use time increment. And the analogy I use for these 2 options is, remember when we create a mesh, you can either do element edge length or number of divisions. So you can either you have a certain set of time. Can you guys see this over here? Let's say you have 2 seconds of time from 0 to 2. You can either tell this that you want 10 divisions, or you can say I want to set the time increment to 0.02 seconds. And then it will go and chop it up into 10 different increments. So that's all I'm using here with time increment. I'm telling it that I want to take a look at this forcing function every chunk of time that I'm going to define. So if we look at this forcing function, and we know we want to analyze from 0 to 0.002 seconds. But if we want to look at what's going on during the whole simulation, we need to tell it that the time increment needs to be less than this, right? We want to have several different points in time that we're analyzing during the load. So what I like to do is either divide it by 10 or 20. So in this case, we'll divide it by 20. So that would be 0.001. So that way from 001 to 002, we'll have 10 different increments that we'll be looking at in this section, and then 10 different increments here. So go 0.00. one more 0. Okay, so that's saying, okay, we're going to look at 10 different increments during each part of this curve. But what also you need to also keep into account over here on the right, saying write items to results file. So we've set this number of time steps, but what this is asking is how often do you want the software to output the data? And we want the data from every single time step. So to do that, you scroll up and you say write every substep. You could do, every other or every 3 or every 5, but we're going to write every single substep. So again, we're manually choosing the time at the end of the load step. We're chopping that up to a bunch of different increments, and then we're saying we want to look at every single increment. So this is the total time, this is the individual chunks, and this is how many times we're going to look at the data.
Why did you use 0.005?
Just because it's longer than this time. You could use just 0.002 as well,
yeah,
but if you want to take a look at what's happening after this, like the response, right, the system's still going to be moving, right, because you're applying a force, so it's going to be oscillating. So you can take a look after the fact as well. For the homework you don't need to, but this software can show you the response. Okay, so that's how you set up the transient analysis. You guys have any questions with that? Yeah, exactly. Yep. Okay, so now we can go and define the loads as we always have done. So you go to define loads, apply, and we're going to fix this node here. So that's structural, displacement, nodes, and we're going to set all degrees of freedom to what? 0. Hit OK. And now we're going to apply a force to node 3. So we go to apply structural force on nodes, and we click node 3, and we click OK. And now this is where things change. So we're not going to apply a constant value, right? Because we know we have this tabular function here. So what we need to do is use this drop-down menu and use this thing called new table. So you click new table, and you click OK. And now it's just asking you to name the table. We'll just name it force. And you click OK. And now what this is asking you is how many number of rows, columns, and planes do you want to associate with this forcing function? Now it's 2D, so you don't have to worry about planes. And you only need one column because you just have force, but you do need 3 different rows because you have 3 different points on the curve that you need to define, right? We're going to have 0, 0, 0.001, 1,000, and 0.002, 0. So we need to set rows equal to 3. You do that right here, 3. So it's the first section, first box here, which is number of rows, and you click OK. So here is your table. And now this is where you define your time, which is on the left. And this is where you define your force on the right. So on the left, you can't just put 0 here for time. And why is that? Our favorite thing to say about Ansys? Ansys sucks. So you have to go a very, 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 very small number. I usually go like 1 times 10 to the negative 7. So something really, really, really small. With force, you can use 0, but with time, you can't. Doesn't make any sense, but those are the rules, and I didn't write them. And now we know for the second time step, it's 0.001, and the force is 1,000.
You did positive 7. You positive 7, change to negative.
Oh yeah, thank you. Thank you, thank you. That would have been terrible. And now our third data point is 0.002 and 0. So this is all you have to do to set up your forcing table. Question? Exactly. Yeah. I don't think you're going to have anything like that. Yeah, Ansys is not the best, like I said. But it's what you have to learn. And it's really not that bad. So here's your 3 points. And to apply this, you just use apply and quit. So you go to File, Apply and Quit. So now, usually right when you apply a force, you get the little red arrow. But when you use the data table, Ansys doesn't give you the red arrow, so you just have to trust that it is there. And now we can solve, right? We've applied all the material properties, boundary conditions, changed it to transient. So we can go to solve, current load step, hit OK, and the solution is done. Close this. And now if you take a look at the data, we are no longer going to use general post-processing. That's what we've used to analyze data throughout the semester, but because this is a transient analysis, we're going to go down to time history post-processing. So you can expand this, and it gives you this nice little manager. And the way you use this manager is with this plus value here. So you can go through. If I click this plus value, it's asking me what data do I want to add to this manager. And we know we want to take a look at, what does it say? Displacements, velocities, and accelerations for both nodes. So to do that, we're going to go to nodal solution, degree of freedom, and we'll get the x component of displacement. Click OK. We'll start with node 2, and we'll do that again for node 3, and then we'll go back to add data, and we'll go to velocity, click OK, we'll use node 2, go to add data, it's already on velocity, hit OK, we'll go to node 3, and then acceleration is the last part, so we go to acceleration, x component, OK. We will grab node 2. And then this is the last one, acceleration for node 3. So that's all the data that we wanted to look at in this analysis. So we can plot all of this very easily by just selecting whatever data you want to look at. And there's this little graph data plot, this little icon right here, the black background and the blue plot. So we are on node 2 displacement. So let's plot node 2 displacement. There you can see from 0 to 0.005 was the window we looked at. But from 0 to 0.002, which is this here, the end of the load. So you can see that after the load's applied, the system is still in motion. And if you were to look at a larger window, you would get a long oscillating effect. So if you wanted to, yeah.
Sorry, how did you get the plot? I just didn't see what you clicked to get.
So right here, there's graph data. Right. So these 3 buttons are the only 3 buttons you really need to use. This is the add data, and this is the plot data. So that was, yeah.
And when you hit graph data, you just graph whatever.
Yep, whatever one you click on here, it's going to graph it. So we just looked at displacement of node 2. So now we can look at velocity of node 2. Again, you can see that oscillating effect. And then if you want to look at acceleration of node 2. And then for node 3, you can plot displacement, We can plot velocity, and we can plot acceleration. You can also plot two things at once. Oh, where did that go? So if you wanted to look at acceleration of both node 2 and 3, you can plot them together. If you wanted to plot velocity of node 2 and 3, you can plot those together. And if you wanted to plot the displacement of the two nodes, you can plot those together.
How do you want us to plot them?
So I would suggest 3 different plots of one of displacement of the two nodes, one of velocity of the two nodes, and one of acceleration. Because if you plotted everything together, the values are so different. Watch what happens when I do this. The acceleration numbers are so much higher, right? So that it makes the velocity and displacement look like 0. So you can't have 3 different y-axes, unfortunately. There's probably a way you could do 2 y-axes, but don't worry about that. So I would just do this for one plot, this for another plot, and this for your third plot. Does that make sense? Cool. Okay. I think that was it. So for, yeah.
In the force table, when we originally added that in, you added those 3 points, beginning, top of the triangle and end. Does it just linearly go between? So if you had like a parabolic, would you actually have to add one?
You would have to, yeah. You had a parabolic equation. You would have to, you know, if this was your y-axis, and this was your x-axis, you'd have to get, you know, this point, this point, this point, this point.
Okay.
And just manually input it. I don't think you're going to have any parabolic equations. How are we doing on time, Ranajai? When does this class end? Alright, I think we have plenty of time. So we're going to do one more.